Okay, good afternoon, everyone. My name is Doug Wagen with UE Systems. We're very pleased to have Martin Robinson with IRIS online with us today. We're going to start off with this webinar entitled Ultrasound and Infrared, the Implications of NFPA 70E and 70B Standards. So ultrasound, many of you know us as manufacturers of our ultrasonic test equipment, the UltraProbe series, and ultrasound is really what we do. But we recognize, it's not the only thing that you folks do. So what we're trying to constantly do is bring you some valuable information that can make your company safer, more energy efficient, and more reliable. So to that end, we've got Martin Robinson here with IRIS, who is very familiar with many different, predictive and condition monitoring technologies, and he's going to talk to us a little bit about NFPA 70E and 70B. So it's a pleasure to introduce Martin. Martin, I'm going to go ahead and switch the screen over and let you take control of the webinar. So welcome everyone, and welcome Martin.
Thank you, Doug. Thank you for the opportunity. Right, can you see my screen okay? Is that it? Make sure it's showing my screen. How's that?
Perfect.
Good. Okay, well, once again, thanks very much, Doug, for the invitation. It's always nice to be asked. So what I'm going to discuss really is NFPA and its implication on electrical inspection. So what we really have to do now to work within the remits laid down by NFPA, but it's always good practice. Obviously, we want to work safe. What you can see here now is what we call an incident pyramid, where we look at the amount of hazardous tasks, and this is in the normal workplace. So this is in the workplace outside of the maintenance industry, where you can see for every 100,000 hazardous tasks, you can expect one fatality. So that's 10,000 near misses, which will produce 1,000 first aid cases with 100 recordable injuries, 10 disabling injuries, but one fatality. Now this was conducted by William Heinrich in 1931, but what was done recently by CAT-Shell was they actually looked at the arc flash pyramid. That's the incidences of arc flash to fatality. Now what you can see here, for every 85 arc flash incidents, you can expect 20 burn injuries with 6 incurable burns over half the body and 1 fatality. So that's a significant increase. You can see the ratio between standard workplace and electrical workplace that, for every 10,000 to 1 near misses to fatality, we're now 85 to 1. Yeah, injury to fatality 1,000 to 1 to 20 to 1. So really, what we're trying to do is avoid at all costs putting ourselves in a situation where we can be involved in an arc flash incident. Now, NFPA, National Fire Prevention Association, was established in 1896, and it really is the world's leading advocate on fire prevention, with over 300 codes and standards and worldwide influence. And because of what I do for IRIS, I travel extensively, and I do see its NFPA referenced globally. And it's also used as an expert consensus to create standards. Now what we're primarily interested in with regards to NFPA is the National Electric Code, or NFPA 70. Now NFPA 70, National Electric Code, NFPA 70B, recommended practice for electrical preventive maintenance, and NFPA 70E, which is what everyone's available for, is the standard for electrical safety in the workplace. 70B is what not a lot of people are aware of, I find, through my travels, especially in the United States. So, National Electric Code, NFPA 70, was established in 1897 by insurers, architectural, electrical, allied interests, but really it was established for this electrical design, installation, and inspection only. It was not designed or put in place to address maintenance or safety. So that's a significant thing. So 70B is the recommended practice for electrical maintenance, established in 1968 to address preventive maintenance of electrical systems and equipment used in industrial type applications. And back then it was with the view of reducing loss of life and property. Now the next revision to 70B came in 2006. I mean, it's almost 40 years later. Now that came in, there was an enhanced focus on safety. There was the importance of baseline performance data, but back then they didn't start. In 2006, we looked at reliability-centered maintenance and how we can integrate that with electrical maintenance. What we recognised back then was, people were using infrared, ultrasound, motor current analysis in much greater numbers. So we needed the ability to give some sort of guideline to the people using it. Now, in 2010, notice another 4 years, there was another revision for 70B, and in that there was a reorganisation of documents including grouping of related topics plus consolidation of test information. So the guidelines for that. There was new material on emergency preparedness and electrical system restoration. New recommendations on how to outsource electrical equipment maintenance. So that's a question a lot of customers I get involved with. They're all saying, if we're going to outsource, how do we do that? And 70B in 2010 gave some guidelines to that. And then obviously then there was a new update to the information on failure modes, effects and criticality analysis, which it really comes into its play when we're doing statistical process control and things like that. Chapter 4 of NFPA 70B is actually entitled Why an Effective Electrical Preventive Maintenance Program, EPM program, pays dividends. And it's a very aptly named chapter. And in that we've clearly stated that dependability can be engineered and built into equipment in line with the National Electric Code, because that's what it's for. But to keep it dependable, you need effective maintenance, otherwise things are going to fall over. So Chapter 11, which was previously Chapter 21 in the 2006 edition, was testing and test methods. Now, in that, it clearly states that infrared inspections of electrical systems are beneficial to reduce the number of costly and catastrophic equipment failures and unscheduled plant shutdowns. Now, infrared inspections can reduce typical visual examinations and tedious manual inspections, and are especially effective in long-range detection situations. Now, when you look at the testing and test methods, it doesn't reference ultrasound in any of 70B, which I believe is an oversight, and that's something that will be rectified in the very near future, I'm sure. But what my company does, and my survey company and the customers, we actually utilise the guidelines for infrared inspections to control the way we do our ultrasound inspections. And that's been a very good practice to date, and I can see that when we actually get the next rewrite of 70B and we include ultrasound, that will be dealt with there. Another thing I get asked about is inspection cycles. When we're looking at test methods, well, 70B outlines up to quarterly, when warranted by either a loss experience, i.e. you have something, a like-for-like piece of equipment, a transformer or something go down. People will, especially if it's in the same life cycle, same age, same load, they may increase the inspection frequency to check what else is on there. New installations is a big one for quarterly, especially quarterly inspections, because most, if you look at equipment where it fails, normally it's in its what we call infant mortality phase. That's where we see the largest amount of failures in the first 18 months to 2 years.
Hey, Martin, I'm sorry to interrupt you. Could you speak up just a little bit? You got a couple people texting in. Some people were texting in saying, could you try to speak up a bit?
Okay, so I thought, all right, so where are we? So new installation. We would increase the inspection cycles when we're looking at new installation. Environmental changes. Anything that, weather-wise or the actual working environment of the equipment, if that changes, you may want to increase your inspections to just see if anything's going wrong, and you'll catch it on the way up. And then the last one is if there are any significant changes in the operation or load conditions on the equipment. You may want to, if you've just, let's say, taken a new feeder out of a switch or increased the load on a switch, you may want to increase the inspection frequencies just to make sure it's not going to fail. And you've not stressed it too much. Now, what it does call for in Chapter 11 is maximum possible loading. And that means that we would, run the equipment in its normal duty cycle to the maximum possible loading we can put on it. That obviously for us as engineers, if I'm doing an infrared inspection or an ultrasound inspection, if it's running at full load, that works very well for me because I'm actually looking at it at its peak load condition. But where it does contradict itself somewhat is what we call open for direct viewer components. But 70B, 70E and OSHA 1910 all call for an electrical safe work condition whenever possible. And we already know that an open live energized panel is not an electrical safe work condition. So when we look at 70E, the standard for electrical safety in the workplace, That was established in 1976 to assist OSHA in developing electrical safety standards. Now in 2007, OSHA stated that it will draw heavily from aspects of 70E and the National Electric Code in a rare revision of 1910.303 subpart S. And what that means is that OSHA doesn't primarily have any standards for electrical safety, and it does lean heavily on the outline and the recommendations of NFPA 70E. So, what is 70E? It's not the standard that tells you to wear PPE, and that's a common misconception. A lot of guys I speak to on site, they think it's, it just tells them what PPE level they need to wear to do a task. What NFPA 70 is the standard that says energized electrical conductors and circuit parts to which any employee might be exposed shall, and must be put into an electrical safe work condition before an employee works within the limited approach boundary of those conductors and parts. Now, the fundamental principle which 70E and OSHA are based upon is what we call the hierarchy of control. And that's really where we can control risk whenever practical. Now, first part of that is to eliminate the hazard if possible. If we can find a way of doing a task and eliminating the hazard associated with that task, that's really the holy grail for health and safety. Now, the other thing is you can reduce the risk by design, and IEEE now have a mandate out to switchgear manufacturers called Safer by Design, or Safety Through Design, where they're looking at equipment manufacturers and asking them to review the routine tasks that are completed on their equipment and to design out any associated risks with completing those tasks. The other thing is to apply safeguards. Last one, implement administrative controls. But the last thing on the hierarchy of control is the use of PPE. Now, don't get me wrong, I am not a PPE basher. PPE is important, necessary, and it should be used at all times. But if you can eliminate a hazard, that's really where we should be aiming for, and that's what IEEE are trying to control. Now, NFPA 70 has 4 boundaries. The approach boundaries, we call them, is the flash protection boundary, the limited approach boundary, the restricted approach boundary, and the prohibited approach boundary. Now, the one that we're most concerned with normally is the flash protection boundary, and that's when we conduct all of our calculations for the arc flash energy and the amount of energy that a worker would be exposed to if they were working within the flash protection boundary. Now, that means that the amount of energy you would be exposed to, you would receive a second-degree burn if an arc flash were to occur, in wearing the appropriate level of PPE. So when is 70E applicable? If a worker is exposed to energized electrical conductors or circuit parts, it's applicable. If you're conducting a risk increase in behavior, it's applicable, such as racking in and out of a circuit breaker, etc. Or you have a reason to believe that the equipment could experience a sudden change in state. So you might smell something, whatever. I mean, that's open to conjecture. But if you feel uneasy about the state of a piece of equipment, then 70E should apply and all safeguards should be implemented. So when de-energized work is not possible, and there are times when de-energized work is not possible, or we conduct tasks live because we've done the right assessments, etc. An energized electrical work permit is required for all work performed within the restricted approach boundary. Now, exemptions for this type of testing are made for troubleshooting, voltage measurement, visual inspection outside the restricted approach boundary, etc. But first you must document the shock hazard analysis, document the arc flash hazard analysis, and document the appropriate level of PPE required to complete that task. Now, these are extracts from the HRC hazard risk classification tables from NFPA 70E. And you can see there that the removal of bolted covers above this is above 1,000 volts to 38,000 volts. You'll be exposed to energized components. It's a risk increase in behavior, and it carries a HRC level of 4. Now, the level is 0 to 4, and that means that you will wear PPE appropriate to that risk. Opening of hinge covers is still a class 3. Contact broke CB operation with enclosure doors open, class 4. CB operation with enclosure doors closed, class 2. Now, a new one for the 2010 edition was performing thermography outside of the restricted area. Yeah, above 1 kV, if the thermographer is standing in front of an energized panel, he will be dressed out in Class 3 PPE, yeah, which is basically a 25 cal suit. Now, the last one I've put on there is the reading a panel meter while operating the meter switch, and it has a HRC level of 0. Now, 0 doesn't mean you walk in now in your Sunday best. It just means that it's not risk increasing. Yeah, but most plants now that I'm involved, especially with electrical safety, a minimum level of dress out for an engineer in his normal working day will be a Type 2 or Class 2 PPE. And you can see there that it's that would mean that you've got a flame retardant shirt and pants or coverall that will resist 8 cals per centimetre squared. So these are the PPE levels from 0 to 4. Number 4, like classification 4, is really very, very difficult to work in, especially if you're using equipment like infrared cameras or ultrasound guns. It puts an inordinate amount of stress on your cardiovascular system, especially as you get older like I am. But we can get caught. There are things, the PPE designers have done their best. They've lightened it up, which makes it quite comfortable. There are some ventilated hoods, some chilled vests. So if you're working in this stuff for any length of time, there are some real advances in PPE to make it as comfortable as possible for you to work. But as I say, what we're aiming for is reducing, minimizing the risk of, taking the risk out of this stuff altogether. Now, an important remark really, and this is from the guys that, the panel, the NFPA panel themselves, is that the collective experience of the task group is that in most cases, closed doors do not provide enough protection to eliminate the need for PPE for instances where the state of equipment is known to readily change, and that's i.e. doors open or closed, rack in or out. So we do even recognise that arc flash incidences are so severe in some cases that they will blow the switchgear to pieces. They really will. You need to consider the anatomy of an arc flash explosion. At its core, it can be temperatures up to 35,000 degrees Fahrenheit. That sort of temperature changes aluminum, copper, steel, all the primary metals inside a switch from a solid to a plasma state instantaneously. That amount of force, 700 miles per hour, the amount of force that 70,000 times its volume it will expand to instantaneously. Yeah, it will throw back hot molten metal shrapnel. That's why you see customers using arc-resistant switchgear, which is designed to not try and contain that force, but to try and vent it to a safer area so no one's put at risk. But the name of the game is to leave the doors closed. But to leave the doors closed, it makes it almost impossible for us to do some of the tasks we need to do. So when we're looking at the uses of infrared windows, ultrasound ports, basically what we see is this is a list of the associated tasks for an electrical inspection, where suit up time for an electrician and an RCM engineer to get in and out of their PPE, it's 30 minutes. Panel removal is 30 minutes. Ultrasound scan will only take, ultrasound and infrared scan will only take about 10 minutes. And then the refit about 30 minutes. So for a standard panel, you're probably talking about an hour or just over an hour to complete a complete RCM inspection of a piece of switchgear working live. And this is an example of 3 engineers working on a piece of plant. Again, this wasn't too bad. It wasn't that hot a day, but working on hot days really is very, very difficult wearing this stuff. So when we're looking at the man-hour analysis of removing panels, two engineers, suit up time, half an hour each is an hour. The RCM engineer, half an hour. So you're looking at an hour and a half to get in and out of your PPE. Cover removal, RCM inspection, cover replacement. The waiting time for the engineers. The 2 engineers who remove the panel have to wait for the guy to complete his ultrasound scan and infrared scan. And vice versa. The ultrasound guy is waiting for the engineers to take the panels off and put them back on. So the manpower per inspection of an electrical panel, the actual man hours, is 3.3 hours. Add to that the PPE time, you're talking 4.8 hours to do a panel. Now, when you build in ultrasound ports and infrared windows, the need to remove the panels goes away. That means the need for the additional labour goes away, and the only guy that's going around, or gal, sorry, going around doing the inspection is the RCM engineer. Yeah, they have complete access to what they need safely. Therefore, the only time is not 10 minutes to do the inspection, no removal of panels, no excess PPE. So you can see by putting in place safeguards to enable you to do your work in line and on full load conditions, but in full laid down requirements of NFPA, 10 minutes versus nearly 4.5 hours, it speaks for itself. So if you're looking at a 5-year man-hour analysis, what would cumulative hours without the ports and windows is 24 hours. We can reduce that to an hour with a saving of 23 hours. Significant savings, and those hours can be used to do the tasks that we need to do rather than removing panels and putting ourselves in harm's way. So this is a CoS scenario based on a paper mill that utilise ultrasound and infrared windows. They had 150 pieces of primary switchgear. The inspections were completed energized in lines with the full requirements of 70E and 70B, which basically meant that the full PPE and the risk assessments, method statements, everything were completed to enable the inspections to be completed in line and to code. Was completed by 2 electricians and 1 contracted RCM engineer. Took about 3 weeks, 150 hours. Now, when we looked at the man-hour breakdown, we looked at it was 63 hours for dress outs alone. Unfortunately, that was way out because we were doing this in August, and those dress outs were more than 2 a day. Guys, you just can't sit in this PPE all day. You really can't. 20 minutes, half an hour, and you need to get out and take a break. You'll start to dehydrate terribly otherwise. We looked at cover removal, the inspection and cover replacement. RCM waiting time. The RCM engineer waiting time, 150 hours of that guy's time is spent waiting for panels to go on and off. And the electrician waiting time is 30 hours for the electricians waiting for the RCM engineer to finish his job. Now the total man-hour for inspecting the panels was 558 hours. 15 hours. Yeah, 3% was productive labour. 97% is unproductive labour. That means the removal of panels and everything else, dressing out in PPE. That is needless time. Yeah, so 543 hours, and 97% of the hours were unproductive. So by installing the IR windows and ultrasound ports, the tasks were completed by 1 person in 30 hours. Now that's significant. The man-hour savings alone on the 5 years was 2,640 man-hours. Yeah. This is an example of an infrared window being used on a tap-off box, and the ultrasound ports that we use on that job are using an Ultrasound 3000 Pro. So the case study here, IR windows were installed on a panel during, this is the TED Corporation, someone that we work with extensively. They installed 44-inch IR windows at a plant in line with the requirements of the customer. On the 1st of July, the switchgear was maintained, windows installed, and put back online. Now, 10 days later, the 11th of July, a fault was identified through the IR window showing a 65 degrees Celsius temperature on a joint, on the switch. Now, due to the nature of the fault, they decided to have another look at it, and they came back at the end of the month. And this is 1 month after a major switchgear repair. Yeah, and they've seen that the temperature had risen to 508 Celsius. Now this is significant. I mean, that was like, this is a showstopper, and even at this stage, the joint was becoming luminescent. At that stage, we ordered the generator sets were ordered, the manpower was put in place, the parts were ordered, the switch was taken offline after the plant was put online on genset, so there was no downtime on this, which is the important thing. The inspections were completed by 1 engineer. They found the fault in complete safety under normal load conditions, yeah, and it was absolutely seamless. Here's the visual inspection of the switches, of the components afterwards, and you can see that the fuse clamp assembly at this stage, the plastic melting knob had even the plastic knob on the old knob had melted off at this stage. So this thing got quite hot. Our estimations by the time we closed it down, it was about 800 Celsius. So this was a great thing about using this type of procedure is you can do a before and after. So, you know, the switch was put back online after the repair. The RCM engineer came back, scanned the switch, made sure we're okay, took an image of the repair and signed it off, which again was done in complete safety under full load conditions. Cost savings were phenomenal on this. The plant didn't shut down. If this plant would have shut down, the switch normally, if you can repair, it's normally 20 times cheaper to repair than replace. So this was a repair. This switch didn't blow up. If it would have blown up, it would have cost a couple of days, at least a couple of days for the plant, and that production time would have cost $7 million. So when you're working with ultrasound and ports in our IR windows, you remove what's classed as a higher risk behavior, and that's the opening of the doors to access the equipment. You maintain what NFPA call an enclosed and guarded condition. That means the switch is closed and guarded, and you're working safe. The fully loaded inspections are completed. You access to what we call uninspectable switchgear, and that's switchgear that you have to de-energize before you open it up because of switched interlocks. Putting these methods in place enables you to leave that switch closed and inspect it safely. The surveys are far more efficient. Yeah, no one is put in harm's way. It's a one-man job instead of a three-man job or a two-man job, depending on how you work. So this is far more efficient, much higher return on your equipment. The control to risk in personal plant and processes is compared to it, much higher. And you eliminate 99% of the triggers of arc flash that would be encountered during this type of inspection. And what we mean by that is if you leave the doors closed and you're working safely, the chances of you triggering an arc flash are extremely low, extremely low. So companies looking to improve profitability, uptime and safety should study the recommendations in NFPA 70B, the standard for electrical preventative maintenance. Now you can buy that standard on nfpa.org. Yeah, I think it's about $85, and if you don't have it, it's probably one of the best buys you will ever make. It's a phenomenal document, and it really gives you the groundwork to get your maintenance program back on track. It's significant that standards value infrared and ultrasound inspections as a critical part of the EPM program. And as I say, that although these standards don't reference ultrasound, it's an oversight. Those of us that use infrared and ultrasound know they go hand in hand. I know my ultrasound equipment can find stuff that my infrared cameras can't. I know there are jobs that I can't put in an infrared window or an ultrasound port, so I use my ultrasound and my infrared hand in hand, and I use I apply the requirements for infrared as laid in 70B and 70E to the same use as my ultrasound guns, and that's a great practice to put in place. Infrared inspections and windows and ultrasound ports provide a way for companies to comply with the recommendations for the inspection processes. I don't have to open up for access. I'm under full load conditions and I'm working safe. Now, NFPA and OSHA agree that electrical equipment should not be opened unless it's de-energized. But again, for us as engineers doing infrared and ultrasound scans, that really doesn't help us do our jobs well. And infrared inspection windows help you to comply, with these standards and maintain. I mean, it's what I call best practice, and I know there's always a thing about best practice, but the fact of it is, if I'm working safe, I'm getting my data as I need it, when I need it, under full load conditions, the chances of me finding a problem on the way up increase significantly. So I'm totally proactive. On our website, iris.com, there's a free booklet called 10 Things You Need to Know About Infrared Windows. You can go on there, download that free of charge, and it has a whole bunch of information on NFPA standards, what's applicable, what's not, and it's a great read. So that's me finished. Doug, any questions?
Yeah, actually, we've had a couple of questions pop in here, Martin. One of them is, do you see in your travels out in the field in companies, do you see sort of a reduction in the number of times people actually test their switchgear because of all the safety issues related to opening them up? I mean, do you see almost a reluctance for people to test them?
Yes, yeah, although that's changing now, thank God. But yeah, no, you're exactly right. I did see, and some very large power companies had walked away from power plants and things, had walked away from their inspections because of the perceived restrictive nature of 70B and 70E. And it really isn't restrictive. I mean, the fact of it is we need these guidelines to make sure we work safely. And I think over the last several years with us doing a better job of educating the guys in the plant, making them aware of the requirements of 70B and 70E. There's been a much greater uptake. The companies have taken on the responsibility of training their staff on the requirements of 70E and electrical safety. So the awareness and the job that a lot of the training organisations are doing out there is phenomenal. And that's had a real good knock-on effect by bringing people back into, should we say, the maintenance world, because they started to experience significant failures that could have been avoided had their programs been in place. But yeah, no, you're exactly right. We did see a big drop-off because of the perceived restrictions, and then once people actually understood what was required and got on board the requirements of NFPA 70E and 70B, the inspections are coming more back online.
Okay. Hey, I hope you got some time, Martin, because I've got a bunch more questions here.
Yeah, no, sure, fire away, mate.
Okay. One is, a gentleman types in here. Hold on a second. They're coming in so fast, I got to scroll back up. He has ABB, Schneider, and Square D switchgear and breaker panels. Wants to install some windows. Do we need to recertify the panels?
Right, we supply all of those companies directly as a manufacturer, but what it boils down to is the requirements of, first and foremost, most people come up with UL. What's the UL requirement? And then are the products. So first and foremost, the products you fit must meet the requirements of UL, IEEE, and any of the switchgear companies directly. So UL clearly state that, even though our products may be UL listed, if you cut a hole, if you change the original design certification of the switch, then really you need to get it reclassified. That's the official line. I always speak to customers, and the way I say to it is that there are many modifications that we make on our switchgear on a daily basis that really change its original design verification. So for instance, we might change the breaker, we might put new line feeds in, we may put a different type of control system in there, we may put different ammeters in there. We would do a gazillion modifications and we wouldn't reclassify because it's something we've been doing for a long, long time. Infrared windows or ultrasound ports are considered, alien to what we do. We're cutting holes in the back or the front or the side of a panel. We're not removing a knockout plate. We're not putting a critter guard on there. We're not doing X, Y, and Z. So there's a lot of trepidation, and I really do understand that. I really do. So my viewpoint on this is that if let's take a corporate view. If your corporate mandate states that any modifications that you do on your switch, you need to get UL back in, or a certification body back in to recertify the switch, and that's exactly what you should do. If it doesn't, then why should putting an ultrasound port or an infrared window change that mandate? So long as you're putting it in and it's correctly tested and certified by UL, IEEE, etc. But the official guide, is speak to UL. They're not ogres, and I'm sure they'll give you more advice, better advice than I can.
Okay, great. Another one is, are ultrasound ports and IR ports one and the same?
No. An infrared window is basically, years ago when we started using windows, we used to use grills. So you'd find IR windows that had a grill. And the good thing about having a grill was that you could do your infrared through it and you could do your ultrasound through it. Yeah. But basically there was no barrier. And as I mentioned in the presentation, we have what we class as fixed and guarded condition. Now an infrared window really should have a lens. That lens should transmit infrared at a given rate that so you can do your calculations. But opening and closing an infrared window shouldn't impede on anything on the high side of the switch. So you wouldn't trigger an arc flash explosion. Yeah. Whereas if it was a grill, it's a vent that you can actually, the outside, what I class it as, if the inside atmosphere can mix with the outside atmosphere, that's not a window, that's a vent or a port. Now, obviously for ultrasound, I can't ultrasound through a solid. Yeah. So an ultrasound port is a port with a hole size no larger than 1/2 inch or IP2X. That's the largest hole size we can have in a piece of switchgear. That has no membrane or lens or anything in it. It's a straight through vent, so I can put the ultrasound equipment up against there, measure, and closed. Now, don't forget, 95% of electrical equipment is not sealed. You do not need ultrasound ports for those. We can go through door seams, we can go through ventilation grills, we can use contact probes. But I do find a lot of my customers now are moving more towards an ultrasound port, primarily in their transformers or switchgear that's sealed. But even in their standard switchgear now, they're putting the ultrasound port because they want a standardized collection point for their ultrasound data, the same way as an infrared window is a data collection point for an infrared camera. And so what they're doing, that they're qualifying that you go to the ultrasound port, you take your data in such a way, you make your recordings, you put it in the file, but by taking it in the same point every time, the quality of the data and the trending is much higher.
Okay, great. Here's another one, Martin. What are the typical components that you need to monitor with infrared windows on switchgear and breakers? And then sort of part two to that question is, can I scan bus bars?
Mm-hmm. Well, right, I mean, scanning bus bar, all you're doing is looking at a load of copper or aluminum or whatever. If you want to look for load and things, if you're looking for really severe load imbalance, I mean, I can look at bus, and if one of the buses is hotter than the other two, then maybe I've got a load issue. But primarily what I'm looking for when I do an electrical inspection is where the bus and cable ties and everything else is bolted together. Where there's clamps or bolts, that's where I'm going to fail. Yeah, so other than that, so when I'm looking inside a switch, I want to see where the bus is bolted, where the cables are bolted off the bus, where the switches are, where the breakers are bolted into the bus. Anywhere there's a bolt or a connection, I want to be looking at any fastener. I want to be looking at that because that's my failure point. So looking at, a common question I get asked by customers, you'll have an 8-foot by 4-foot cabinet, and for years they were opening the doors and scanning the whole cabinet, and their thing is, well, I can't put an infrared window in there or an ultrasound because I can't see the whole cabinet. And the relevant question to ask is, well, what do you want to see inside that cabinet? I don't really want to be looking at all the bus and the cable. I want to look where all this stuff is bolted together. And that actually, then when you look inside a cabinet, you can actually specifically look at what we call key target areas. So an 8-foot by 4-foot cabinet might only have 3 or 4 key target areas that are maybe 18-inch square. So you can, once you look at that, you can download a lot of that. The book I advise everybody to download off our website, like 10 Things You Need to Know, that gives some really good information on identifying the targets inside the cabinets when you're doing your inspections, etc.
Okay, great. Here's another one, Martin. What's the guideline for using a face shield when scanning open door MCC buckets, 480 volt?
Again, if you look at the HRC tables, most of you can have a type. Well, normally there's a starred in there. I know, for instance, when I look at the HRC tables, if I am standing, most guys I know now going around, a lot of companies, they've got guys wearing full face shields because they're not uncomfortable to wear. You just attach them to your helmet, and they're wearing it in lieu of safety glasses a lot of the time. But basically, if there's a starred, and I think it's 1 and above. But again, I haven't got the stand in front of me, and I'm having one of those brain moments. But, please, you can email me m.robinson@iris.com, and I'll come back to you with a very specific answer on that. You have to forgive me. Sorry.
Great. Another one here. I read there's a possibility of incorrect readings through IR windows as compared to an open panel reading.
Definitely. It's called transmission rate. And the transmission rate of the materials utilized in the infrared windows really depends on many, many things. But you need to know what the transmission rate of either the crystal or the polymer or the whatever you're using is your lens. Now, we have what we call a fixed and stable transmission rate, and again, I'm not going to really go into that because it gets very commercial and there's a lot of conjecture on that, but yes, the transmission rate of the material will change. It can change with age, it can change with temperature. That's for sure. We can show you techniques of how to measure that transmission, and depending on the materials you use, they won't change. But again, it's called transmission rate, and yes, it does change, and it does change with even different cameras, and that can get very technical. You can take 3 different cameras, look at the same target temperature through the same window, and you'll get 3 different readings. and that sounds really confusing, but that you get the same difference with the cameras themselves as well. It's just the detectors that they use. But again, download that book, and there's some other information on that. And if you want more information, you can contact me directly anytime, and I'll help you out.
Just a couple more here, Martin, if you don't mind.
No, sure, fire away.
What kind of training is available on NFPA 70E and 70B? Like, and where is that available?
Oh, there's some phenomenal training associations. I mean, one that comes to mind, someone I deal with quite a lot, is Shermco. Great guys, really good training, and you know, some of their trainers are NFPA standing committee members. You've got guys like ArcSafe, Hugh Hoagland, PPE guy. They do some great NFPA training. I think Shermco are based there in Texas, but a lot of these training organizations, if your company wants to run a program, they'll bring the inspectors into you. You can actually fill up a classroom, book a trainer, they'll come in and run the training courses on site as well. But two that come to mind for me is Hugh Hoagland at ArcSafe and Shermco. But there are many, many more. Fantastic.
I've got another one here, Martin. This looks like it's specific to a window. It's, on the VP12 data sheet, does it show that the unit is NFPA 70E compliant?
There's no such thing as NFPA 70E compliant. NFPA 70E is a standard for electrical safety. When we talk about compliance, we're talking about the working within the remits recommended within the standards of 70B and 70E. So NFPA 70, there's no such thing as a compliant window or switch or whatever, because that's just a recommendation for safe working practices. So when we talk about that, we're talking about working within the remits laid down by 70E or 70B. I hope that sort of clears that up.
Okay. Another one here, do insurance companies require switchgear inspection in facilities?
You'll find yes. And you've got to look at that as a thing. If I was carrying the risk for your plant, I would require an annual infrared inspection of your electrical distribution system before I would sign off on it. And you will find, depending on your carrier, most of my companies I deal with globally, the main driver for the infrared inspection annually is the insurance company.
Okay. Another one here, someone writes in, he has heard and seen online something about an arc flash university. What is that?
We sponsor that through Plant Engineering. The Arc Flash University is a what we have done, and in fact we do that with you guys, Doug, and Square D Schneider, is we bring in industry experts to talk about the issues relating to either safety or compliance or even switchgear design. So for instance, we gave 3 webinars this year. We had Mike Doherty from the Canadian Standards. Mike was the chairman of the CSZA 463 committee or 462 committee. Mike's a great guy, real good safety guy. So Mike gave a presentation on NFPA 70E and CSZA 462 and how it applied to safe works in electrical inspections. We had Square D Schneider give a presentation on switchgear design and advances in design, and we had Lanny Floyd recently from DuPont gave one on compliance and how to comply with the requirements of certain standards to do our job safely. So Arc Flash University is about giving back information to our clients, very similar to what we're doing here. It has nothing to do with windows or ultrasound equipment or anything. It has everything to do with safe best practices relating to electrical equipment maintenance and design. So that's what, and again, in 2011, we've got the honor of sponsoring that. Iris and Yui and a number of others are going to be sponsoring another 3 key webinars on those subjects. So very worthwhile to attend.
Excellent. How about, here's another one for you, Martin. Does IR work with Fiberoptics for those switchgear cubicles having internal covers?
No. But what we use, there are a number of, I know you talk about metal clad gear when you've got stab connectors or electrical connections behind internal cladding inside the switch. There's a number of modifications we've done with switchgear companies. We use standard heat transference techniques and things like that. I can, you know, again, anytime, drop me an email. I can give you more information on that. And as 10 things you need to know about IR windows covers that subject in a little bit more detail.
Fantastic. Thanks so much, Martin. For those of you who still maybe have some questions, you certainly are welcome to email those questions in to Martin, which is m.robinson@iris.com. Or you certainly questions are welcome to info@uesystems.com. Either or, both Martin and we will certainly share that those questions, and we'll certainly get back to you. This webinar is also going to be available on our website. We've recorded the entire webinar, so it'll be on uesystems.com coming up here probably within a week or so. So certainly if you missed it or you have colleagues or friends that you'd like to pass this information on to, you know, feel free to do so. Martin, thank you so much. That was fantastic, informative.
No, thank you very much for the opportunity to speak. I appreciate it. And say, anyone needs anything, we're always here.
Fantastic. Thanks again, Martin. And
Take care.
thank you all for attending.